Okay, so we're going to do questions 1 through 15 on the end of course review for your final. The first one's asking us to graph a trig function. So remember that when we're given a trig function in the form of y equals a times sine of b theta, the amplitude of the function is the absolute value of a. So for this one, that means amplitude is 2. So that tells us we're going to go up to 2 and down to -2 on our graph. And then the value for b helps us find the period. So to find the period, we do 2 pi divided by that value b. And so since our b here is 2, we're going to do 2 pi over 2, which is pi. So what that means is that we have a full cycle going through at pi. On our graph, remember, we did that period value divided by 4, and that gave us what each measure was going to be for 4 x values on our interval. And then we'd take pi over 4 and we'd add pi over 4 to it to get the next value, which that gives us 2 pi over 4, which is pi over 2. So notice that we have pi over 2 already on this graph and pi. That means let's make a live here. Let's call that pi over 4. And we have pi over 2. So if we add another pi over 4 to 2 pi over 4, that gives us 3 pi over 4. And then that's going to give us 1 full cycle if we add pi over 4 again. So that gives us 4 pi over 4, which is pi, which is the end of that. So I'm just going to add in these little halfway points so that we can get 2 full cycles on this graph. Remember that because we're graphing a sine, our y value pattern is 0, a, 0, negative a, 0. And so since our a was -2, we're going to start at 0. At the next point, we're going to be at -2 and 0, then +2, and then 0. And then our pattern just continues. So we're back at 0 as the start, and then we're going to go to a, 0, opposite of a, 0. And so the graph of this sine function looks as so. For question 2, we're just doing amplitude and period. So that's just doing these first 2 parts. Remember that what is true here is only true for sine and cosine. For tangent, it's a little bit different. So remember that the graph of tangent has arrows going on forever. So there is no amplitude for a tangent graph. And the difference with the period is that it's not 2 pi over b. Instead, it's just pi over b. So since b is 6, the period for that graph is pi over 6. What does that look like at b? So let me fix that to look like more like a 6. So then for this -3 sine of 2 theta, the amplitude then is +3. For 2 cosine theta, the amplitude is +2. And then for the last one, the amplitude is +1/3. Remember, this amplitude is always positive. So if there are any options on your multiple choice test that give you a negative amplitude, you can eliminate those automatically and then just look at the period for the ones that aren't. So then our period, we're taking 2 pi and dividing by b, which will give us, for the first one, 2 pi over 2. Means that our period is equal to pi here. And then we have 2 pi over 6. So if we simplify that, the period is pi over 3. And then finally, 2 pi divided by pi tells us that the period of this last one is 2. Okay, so we're building with number 3. And we're identifying amplitude, period, but then also phase shift. I'm going to do vertical shift as well because vertical shift is here. So for a sine cosine graph, the amplitude, remember, is the absolute value of a. Since a is -1/2, that means the amplitude is +1/2. For the period, we're looking at the number after cosine before x. Since there isn't one, that means that it's 1. So the period of this is 2 pi divided by 1, which is just 2 pi. Remember that the phase shift is essentially the h value, and since h is always inside parentheses, it's the opposite of what you see. So h here is negative pi over 2, not positive pi over 2, which tells you that the phase shift for this graph is going left pi over 2 units. And since we have an amplitude, or sorry, a k value there, even though it's not asking us, let's determine what that is. So the vertical shift is the k value. This number 3 is the value for that, so this is -3. The vertical shift is down 3. Okay, so we started with some things that were more recent. These are a little less recent. And so let's look at the question for number 4. So this is asking us for the horizontal and vertical asymptotes of the following rational functions. And a vertical asymptote we'll start with is the zeros of the denominator. So what we're going to do is factor the denominators and see what the zeros are. So for this one, we can actually factor everything. So if I think about 2x plus 6, 2 and 6 share 2, so I can factor out 2, and I'm left with x plus 3. And then for the denominator of x squared minus 9, that's the difference of 2 squares. And so that means that it factors as x plus 3 times x minus 3. So if I have a vertical asymptote, it's a value that remains in the denominator and makes it undefined, not something that cancels. So notice that the x plus 3's cancel. So this is actually equivalent to having just 2 over x minus 3. That x plus 3 value is going to give you a whole. And so the vertical asymptote for this graph is at x equals 3, because that's the value that's going to make this 0. So remember, we always take the opposite sign of what we have there, and that will give us that vertical asymptote. For the next one, I can't factor x cubed, but I can factor 24x squared minus 10x plus 1. And so for this, I'm using the star method or a product sum with that kind of additional step. I'm just going to use star because it's a little more compact in terms of the work. So remember that I multiply 24 times 1, which gives me 24. So I need two numbers that multiply to 24 and then add to -10. And then I'm putting 24x here because I know that that's what my two things need to eventually multiply to. So two numbers that multiply to positive 24 and add to -10 are -4 and -6. And so that means that this guy factors to become, if I simplify 24, I can divide by 4, and that gives me 6x minus 1. Similarly, I can divide this one by 6, and that's going to give me 4x minus 1. And so remember, to find the vertical asymptotes, what we talked about is we're going to find the zeros of these. So I would take and set each one equal to 0 and solve. That'll give me two values. That'll give me x equals 1/6 and 1/4. I know, I'm kind of smushed right there. So that's our vertical asymptotes. Horizontal asymptotes, it comes down to the degree of the numerator and the denominator. So if I look at the terms with the highest power, this is a higher degree. That tells me that the horizontal asymptote is at y equals 0. If I look at the degree here, this is a higher degree. And that tells me that there is no horizontal asymptote.
What? What did you say?
Pepper, hold on. Okay, sorry. So if we had something, the other situation is if they have the same degree. So for example, if instead we had, and I'm just going to draw over here so that you guys can see this. So if we have like, let's say we had 2x plus 5 over x minus 3. The way that the horizontal asymptote would work, if these are the same, is it would be that we do y equals essentially just their coefficients. So we'd ignore the x's. So the y would be 2 over 1 plus 2 over 1 or 2. Okay, so if they're the same, then it's really just the fraction of the coefficients. If the degree is higher in the denominator, it's y equals 0. If it's higher in the numerator, there is none. Number 5, we have a triangle, and they're asking us for a side. And so if we look at the angles, we have 110 and 50. It's not a right triangle because that adds to 160. And so that means that this angle would have to be 20 degrees, right, in order for us to have a triangle. So if I add those, I'm really doing kind of in my head 180 minus 110 minus 50, and that gives me 20 degrees. And so I know that this is not a right triangle, which means that I have to use one of my formulas. Okay, so I know all 3 angles in the triangle, and I know one side. So since I know more than one angle, I'm going to flip to the back, which is the formula sheet. That tells me that I have to use the law of sines for this one because I pick 2 things and I can use 2 angles and one side, as opposed to with law of cosines. I either only know one angle for the top standard form. For the alternate form, that's if I don't know an angle, I only know sides. So I'm going to use the law of sines. So I need to figure out which one do I know an angle on a side for, and then that's something that's going to go within my formula. So since I know, oops, that was supposed to be a highlighter. So since I know angle C and across from it side C, that tells me that I need to use sine of 110 over 12 equals, the one that I want to know is A, and so I have to use that as well. So that 20, sine of 20 over A is what I'm looking for. Remember, with law of sines, what I have to do is cross multiply. So I'm going to multiply A times sine of 110 and set that equal to 12 times sine of 20. And so since I want A by itself, I'm going to divide both sides by the sine of 110. And then I am just going to calculate this 12 times sine of 20 divided by sine of 110. So double check your calculators in degree mode, because I know we did do some things in radians. We do want it to be in degrees for these problems because of things like this. So I'm doing 12 times sine of 20 divided by sine of 110, and that gives me about 4.4 for my answer. Okay, so remember that we can kind of think about if this side's 12 and that's the largest side, my answer for 20 needs to be a lot smaller than 12, so 4 seems reasonable. Okay, so number 6 is a composition of functions. So remember that when I have something like this, I work from the inside out. So the first thing that I want to find is g of 4. So I'm going to take 4 and plug it into my equation for g of x. So g of 4 means they want me to find the square root of 4. And so I know that the square root of 4 is 2. So then what I'm going to do is plug 2 in for my g of 4. So they want me to find f of g of 4. Means that now I know that g of 4 is 2. So I need to find f of 2. Okay, so again, I'm building. So if I plug 2 now in for f of x, f of 2 is going to give me 2 times 2 squared plus 2 times 2 minus 1. So that's going to give me 8. So 2 squared is 4 times 2 is 8 plus 4 minus 1. So that means that we're going to get, what's that, 11. Okay, so the next one we're talking about a parent function of a square root. So it's reflected across the x-axis and stretched vertically by a factor of 2. That's describing A. So the reflection part is telling us that A is a negative number. The vertical stretch is telling us that it's actually 2. Okay, the shifted left 3 units is telling us that H is -3. And then the down 1 unit is telling us that K is -1. And so what that gives us in a square root function, remember that we're looking at y equals a times radical x minus h plus k, means we have -2 times the square root of x plus 3 minus 2 as our function. For 8, they're giving us 2 equations. So f of x is x squared minus 1, g of x is 2x plus 4, and they just want us to add them together. So we're just literally taking x squared minus 1 plus 2x plus 4, and we want to write that in standard form. So for x squared, we only have 1 term. For x's, we only have 1 term. And then for the constants, we just have plus 4 minus 1, so that's going to give us a plus 3. So f of x plus g of x then is x squared plus 2x plus 3. For number 9, it's just like number 7, and then except it's an absolute value. So the only thing that changes is really that we're looking at absolute value instead of a square root, but the structure of it is still the same. So it's a times the absolute value of x minus h plus k. And so if it's reflected across the x-axis, notice there's nothing about a stretch. That's giving us the value for A as -1. So there's no number, tells us that it's 1. If we're going up 2 units, that's giving us the value for K. So this tells us that K is +2. And then going right 5 is telling us that H is 5. So if we're plugging into this equation, we've got y equals negative absolute value of x minus 5 plus 2. Number 10, we need a little bit more space than it's given. So I want to cross multiply when I have a proportion. So I'm going to take 3 times 2, which is 6. And over on this side, I'm going to set that equal to x times x minus 1. So I'm going to multiply to simplify this. So I've got 6 equals x squared minus x. Since I have an x squared, I'm going to want to factor to solve. So I'm going to subtract 6 from both sides. And so 0 equals x squared minus x minus 6. So what I'm looking for then is how does this factor? And so really I'm thinking about what multiplies to 6, that's my product, and then what adds to -1 as my sum. And then those two numbers that we get then are -3 and +2. So that means that it's x minus 3 and x plus 2. Since I'm solving, this means that my zeros are 3 and -2. Okay, so I'm going to write my answer right here, but we still have to check. So if we check, we're ultimately just making sure that nothing goes undefined. So I'm going to plug in the 3 first. So 3 over 3 equals 3 minus 1 over 2. And so that 3 over 3 equals 2 over 2. And notice both of those equal 1, so that number is good. We do the same thing with the -2. 3 over -2 equals -2 minus 1 over 2. This is -3 over +2. So no matter what the negative is, it's still a -1.5, right? So both of these equal -1.5, and so those are both correct answers. So for 11, we're solving a log equation. We have to use a couple different things. So remember that with properties of logs, when I have multiple logs, If I'm subtracting them, that turns into division. If I'm adding them, that turns into multiplication. So since these are being subtracted, I can think of it as a single log, base 2 still, of 3x minus 1 over x plus 2. Okay. So from here, what I have to do is switch it into exponential form. So one thing to remember is that this in exponential form is equivalent to 2 to the 1 power equals 3x minus 1 over x plus 2. Okay, so remember that when we had something like this, log base b of x equals y, that was equivalent to b to the y equals x. And so I use that property in this step. Now this problem looks a lot like the previous in that 2 to the first power, but I can think about that as 2 to the first power over 1, so just 2. And then I can cross multiply. So if I multiply 2 times x plus 2, I've got 2x plus 4 if I distribute that. So I'm multiplying here. And then 1 times 3x minus 1 is just 3x minus 1. So I need to solve for x, which means I need all my x's on one side. So since 3 is positive or bigger, let's move the 2x over. And then that'll give us 1x over here. At the same time, let's also add the 1 so that we can do it all in one step. That gives us 3. So 3 equals 1x. That means that x equals 3 for this problem. For number 12, we're going to use this property that I wrote down over here to convert to exponential form. So remember, whenever I have something like this, I'm thinking about it as being equal to x. And so I want to think about 3 to what power equals 9. And since 3 squared equals 9, that tells us x equals 2. So our answer for this problem is 2. So similarly, if we think about this one, 7 to what power equals 343. And the answer to that is 7 to the third power. So then here's 6 to what power equals 6. And that's 6 to the first power. For D, it's a little bit different. This is actually the change of base formula. So the change of base tells us that log base B of A is equal to log A over log B. And so that means that this originally is equal to log base 3 of 9. And so notice that is what we had for A. And so that means that this answer is also 2. It's the same problem, just written a little bit differently. Okay, so number 13, we're almost done for today. We're going to find the inverse. To find the inverse, remember the first thing that we do is we actually switch x and y. So remember, f of x is equivalent to y. And so we're going to rewrite this as x equals 3 times y squared plus 6. And we want to solve for y. And that value, that expression that we end up with will be the inverse. So we're going to subtract 6 from both sides. Most of these, we won't be able to simplify anything. So that gives us x minus 6 equals 3y squared. Then we're going to divide both sides by 3. Since we have more than one term here, we want to divide everything by 3. So if I divide x by 3, that's 1/3 x. And then 6 divided by 3 is 2. So I have 1/3 x minus 2. And that equals y squared. To get rid of the squared, we have to square root. Remember, when we square root, we have to write plus or minus. So we have this plus or minus the square root of 1/3 x minus 2. And that is the inverse of 3x squared plus 6. Okay, so we got 2 more. We're looking for the volume of a cone and the volume of a cylinder. So if we refer back to our formula sheet, those are included for you. And again, these are the formulas that you'll have on your test with you. It'll be a better copy where you can actually read the unit circle. But these are all the formulas you'll have. So for this problem, we need both of those formulas. So let's write them down next to the figures. So this one is a cone, so it's 1/3 pi r squared h, and a cylinder is just the pi r squared h. So here our radius is 3 centimeters. Here our radius is 4 centimeters. And then on the cone, our height is 11 centimeters, and on the cylinder, our height is 15. So we're just plugging in those values and calculating. So 1/3 pi times 3 squared times 11. So what you can do is just really plug that in, or you can simplify so you have less to plug in. So 1/3 pi of times 9 times 11. I can simplify the 3 with the 9, and 9 divided by 3 gives me 3. And so I can think about this as pi times 33, or 33 pi. And then that's a little bit faster to type into the calculator. So if I multiply 33 times pi, that gives me about 103.7. And since it's centimeters and volume, they're going to be cubic centimeters. So either one of these, depending on what your answer choices look like, either 33 pi or 103.7 cubic centimeters. For the cylinder, we're plugging in 4 and 15 instead. So pi times 4 squared times 15, or pi times 16 times 15. So that gives us 240 pi cubic centimeters, or if we are doing something, if it gives you decimals for your options, you're going to multiply that by pi, which is about 754. It rounds up. Okay, so then for the last one we're going to do today, we're writing the conic standard form. You should recognize this is a circle and know that it's a circle because I have x squared and y squared. So when it's a circle, I want to move everything over. So I'm going to have x minus h squared plus y minus k squared equals r squared. So I want to add 28 before I do anything else, and then I'll set it up so that I can complete the square in this step as well. So I'm going to have x squared plus 6x plus blank plus y squared minus 4y plus blank equals my 28 plus 2 blank so that I can complete the square. So remember that when I'm looking at this, I know this is going to be x plus 3 squared, because when I'm completing the square, I take b and divide it by 2. And then I square that value, which in this case, 3 squared is 9. When I do it with the y, I'm taking the -4 divided by 2, so I get x minus 2. Sorry, not x, I get y minus 2. And then when I square that, 2 squared is 4. So I'm going to add 9 and 4 onto my 28 to get the radius, which means that we're going to have what is that, 41? 20 plus 9 plus 4, yeah, 41 for this value. So the standard form of this conic looks like that. Okay, so that's all for today. Tomorrow we'll do 16 to 30, and then we'll do 31 to 45 on Wednesday.